Hi guys, and welcome back to the channel. In this video, we're going to react to why is the weather getting wilder? Like here in the UK, and I think in America as well, North America, and to be honest, all over Europe, probably all over the world, the weather is it's for me, undeniably, it's getting really weird. It's all over the place, you know. Like sometimes it feels like I'm experiencing 3 seasons in a day. Like it will go from being cold and raining to, like, you know, in the morning you get to 1 o'clock, it's warm, like 25 degrees like Celsius, the sun is shining. Then in the evening it will be super windy, it's like and dark. I just what is happening? And I think in America, like, you know, you're seeing things happening. I think there's a hurricane in Florida, you know. You've had fires all over Europe, you know, you've had extreme heat in places that don't usually get extreme heat. It's just, the weather is getting really, really, really weird. And I just, you know, hopefully this video is going to answer it. Is it climate change, or is there another reason? Is this actually normal? Maybe, I really don't know. So I'm going to go into this with an open mind, and yeah, hopefully we get some questions answered.
We've seen so much extreme weather recently that it's hard to keep up with all the records that have been broken. In fact, in 2021, 10.6% of all weather stations recorded record temperatures. It's easy to blame global warming, but extremes have not only become hotter and drier, they've also gotten wetter, snowier, windier, and colder. So we have to dig a bit deeper to understand why and where these extremes are happening so that we can prepare for what's actually coming our way.
In this episode, we're going to explore groundbreaking new research that reveals one common factor connecting almost all of these extremes and even suggests what we can expect in the future.
And to do this, we'll start by zooming out, way out to the troposphere. Then we're going back in time by drilling into Greenland's ice sheet to uncover clues about our very uncertain future.
The changes we experience in our climate and weather are fascinating and definitely overwhelming at times. But the more we understand about what's happening both today and down the road, the safer we can be. And if you want to see more content on changing weather and how to prepare, give us a like and subscribe. Let's dive in.
Let's go.
The jet stream is this meandering, waving, buckling band of west to east moving winds that are situated in the mid latitudes. And they're really important for us as humans in our day-to-day lives, because the jet stream seems to dictate much of the weather that we experience. So any change in weather that we have actually is related to how these upper atmosphere winds are changing.
And as we'll see, shifts in the jet stream connect most of the extremes we saw in 2021.
The jet stream forms where warm air from the tropics meets cold air from the poles, and it moves weather systems from west to east due to the rotation of the Earth. Without it, we'd see far fewer changes in our daily weather.
Exactly how much effect climate change has on the jet stream is hotly debated, but Judah Cohen is a climate researcher whose work focuses on this exact question.
Strength of the jet stream is very much dependent on how large is that temperature difference between the equator and the North Pole. The Arctic is warming 2 to 3 times faster than the rest of the globe. So that means that temperature difference is slackening or weakening. With a weaker temperature difference, also the jet stream is kind of weakening or slackening. The winds are not as fast. Now that I think everybody agrees on, but there is kind of this new idea that really didn't exist 10 years ago, that this weaker jet stream also leads to slower moving weather systems and also a more amplified or greater waves inside the jet streams. If the waves in the jet stream have much larger north to south extent, there's much more vigorous mixing of air masses. So you bring cold air from, you know, let's say the Arctic or in Alaska County, bring it down to Texas and Georgia, right? And so it's very anomalous. You know, if it's cold in Fairbanks, you know, they can handle it. They're used to it. When that same cold air is quickly transported into...
Yeah, this is what happened in Texas with the I think they called it a snap freeze or something like that. You know, people didn't have power, I think, for multiple days and stuff.
Dallas, Texas, or Atlanta, Georgia, they're not used to it, and it causes havoc with our infrastructure. And
Oh my God.
This theory may be new, but 2021 made a pretty convincing case. In fact, it's hard to find examples of major weather events from last year that aren't connected to the changes in the jet stream.
The Texas deep freeze was caused by the jet stream becoming so wavy that it brought Arctic air from the poles to the southern U.S. Later, the jet stream was so coiled.
Minus 21 Celsius. Bloody hell. Wow. I mean, the coldest I've experienced was like -9, -10. This was on a night out when I was in uni. And man, that was cold. Because I was only wearing a t-shirt. I didn't want to pay for the cloakroom, because you had to pay £4 for the cloakroom. And obviously students were broke. So yeah, that was cold. Minus 21?
And slow over the Pacific Northwest that it trapped a high pressure system over that region, allowing hot summer sun to heat stagnant air to new highs. A similar pattern caused flooding in Europe and fires in Siberia. Then Hurricane Ida slowed as it hit the Gulf states, and instead of being pushed offshore by atmospheric winds, it was blocked by a high pressure system and dropped record rain over the eastern U.S.
So, I mean, how do we build resiliency to climate change? And it really will come down to a large part changes to extreme weather. And again, extreme weather is very much strongly connected to changes in the jet stream.
Okay, and that is happening more because of Arctic amplification, correct?
So that, this is a controversial idea. That's an argument that I'm making.
And Judah is not alone. So we'll see in the coming years how this debate plays out. But it's not just wind direction and speed that can change. In fact, the entire system might be migrating, which could mean even more significant and long-lasting changes to our climate at ground level. Matthew Osman from the University of Arizona's Climate Systems Center recently discovered chilling data that suggests the jet stream is moving north.
If we want to understand how climate change is going to evolve in the future, we need to understand how and why it has changed in the past.
Okay, so how do you figure out climate changes and jet stream locations before satellites were documenting them?
So in this case, what my team was able to do was to collect measurements of glacial ice from across Greenland and combine those measurements together in order to dissect properties of the climate that are related to changes in the jet stream.
By doing this, they were able to find changes in the jet stream's position and intensity going back 1,200 years.
It's like the whole global warming thing. Someone said to me that we're just going through a hot cycle. Apparently the planet has cycles where it heats up and then cools down, and that, humans aren't really, affecting the climate that much. I don't know if I believe that, because, I've heard several people say that, yes, the planet does go through cycles, but it's heating up way faster than it has in the past. And maybe that's the human element. What do you guys think? Do you guys think that we're, accelerating the heating of the planet, or are you kind of a skeptic there?
And they found evidence of big changes.
Going back 1,000 years into the past, we see that changes in where it's positioned across space can be on the order of 10 or more degrees latitude. So this is a lot of area that the jet stream is covering on these really long time scales. And this, of course, has big impacts on changes in weather that we've seen over the last millennium.
Over the last 100 years, we've been emitting greenhouse gases into the atmosphere, causing the climate to warm. And remember, the jet stream is created where warm southern air meets cold northern air. And if the Earth warms, then the place where those air masses collide might move north because there's less cold air.
So what we've seen is this slight trending of the jet stream's position towards the north over the last 40 years, but it hasn't been clear whether or not this is driven by natural changes or whether this is human caused.
And one convincing way to separate human-caused jet stream migration from its natural variability is that the jet stream's average location goes outside of the historic range.
And what we can do is actually compare projected changes in the jet stream that we get from models with the range of variability that we see in our reconstruction. This is essentially the range of natural variability. And what we see is that for high greenhouse gas emission scenarios, we might find ourselves in a position where the jet stream becomes effectively distinct from the range of natural variability within the coming decades by as early as 2060 CE. Observations that we have from satellites, as well as estimates of the climate system that we get from models, both agree that the onset of changes in the jet stream's position has already began. It probably began about 20 years ago in the late 20th century. And this is really important because when we start to think about climate extremes, right? So extremes in precipitation or temperature, we care about where the edges of those variations exist.
This is because as the jet stream migrates beyond the limits of its historic range, we're likely to see even greater extremes in our climate than we're used to.
Okay, damn. So basically, it seems like it's just going to get worse. Because I was thinking, because they're talking in a lot of technical terms, but yeah, that last bit doesn't sound very good, does it? Man.
If we continue to emit greenhouse gases, we will see a migration of the jet stream further and further to the north. And as we push the North Atlantic jet stream outside its natural range, we will see consequences in where the temperature extremes as well as precipitation extremes fall for the places where you and I live today.
If this pattern continues to play out, places like California and much of the American Southwest will keep getting hotter and drier as the jet stream delivers less and less moisture from the ocean, while some more temperate regions like the Pacific Northwest will receive even more moisture than they currently do.
This means many already dry regions becoming drier and wet regions becoming wetter. And the same pattern would likely hold true across much of southern and northern Europe.
Yeah.
Our understanding of these changes is still evolving, but Matt and Judah's work underscores the need for preparation. And I, for one, feel a lot better when I understand and when I'm ready for what's coming our way.
Yeah, definitely.
For a deeper dive on how to cope, check out our previous episodes on drought, flooding, and winter weather. And finally, we'd love to hear what you think about this subject, as well as...
Interesting video. And it's an interesting one because, ultimately, if we can't get China and India to reduce their greenhouse emissions, those are the two, I think they are the biggest two emitters of carbon emissions right now. I'm not saying that, what we do in the UK, Europe, and US is meaningless, which that's not true. Obviously, if we reduce ours, then it does contribute to the global amount. But if we can't get the two really big players to, come down, it's just gonna, the efforts that we put in, with electric cars and, solar and stuff like that. I'm not gonna say it's meaningless, but it just doesn't go as far as it could. So I think because the weather for sure, I've noticed it, man, it's just all over the place. It really is. This summer was just weird. I'm not saying that in the UK we get consistent heat throughout summer, but it's been all over the place. You'll have one day of really good heat and sunshine, the next day it's raining. Sometimes it's changing midday. It's just bizarre. I don't know what's going on, man. Thanks for watching, guys, and I'll see you in the next one.